So the first group of fish were, remember, agnathans. So they lacked a jaw. So gnathostome, this means jaw around the mouth. So these are my jawed fish. You will remember that we talked about mechanisms of macroevolution and how things generally do not just appear out of nowhere. So we could ask, where did the jaws come from? What are the jaws derived from? And so one of the things that we see is that there are skeletal elements that support the pharyngeal gill slits. So this would be like a jawless fish. This would be like a lamprey. They have these skeletal elements supporting their pharynx. When we look at jawed fish, they have fewer of these gill arches. And some of those, they believe that those gill arches have become the jaw. So when we talk about the evolution of the jaw, this is a modification of bony gill structures called gill arches. Interestingly, we have a remnant of a gill arch in our body. It sits right underneath your jaw, kind of floats there, and that is your hyoid bone. It is shaped very much like a gill arch. We use our hyoid bone because that's kind of like where our tongue attaches, and when we swallow, it's helpful. But that is our modification. So if we look at these, you'll notice that this looks like a shark because those are the first jawed fishes. And when we look at shark jaws, they are super simple compared to our jaws. So our jaws are little, as mammals, are a little bit more complicated than the jaws of, say, for example, sharks. So let's look at those first fish. This is actually not a shark. This is what is called an armored fish. These are actually the first fish that we see in the fossil record. These are called placoderms because they're armored fish. They are only seen in the fossil record, but they have these almost like an exoskeleton, these bony plates, even bony plates around their eyes. This is huge. This is 1/2 meter. So they had these big, huge fish, and these were the first fish that had the jaws. But the placoderms are extinct. Okay, we don't see them. We only see them in the fossil record. Kind of maybe a good thing. Okay, so let's look at the chondrichthyes. So you do need to know this word. Ichthyes means fish. Chondra means cartilage. So these are my cartilaginous fish. They have a skeleton that is made of cartilage. We, as embryos, have a skeleton that is made of cartilage. And so it's actually believed that these evolved from bony fish. So I'll put that thought, that's the current thinking, thought to have evolved from bony fish. They retain their juvenile skeleton, and it is cartilage. We have a name for this mechanism of macroevolution. This is called paedomorphosis, or neoteny, right? So this is a mechanism of evolution. So they retained that. Our bones, even as we're fetuses, start to ossify. So they go from being hyaline cartilage, and then the matrix becomes calcium rich, and it becomes more brittle. But this is not the case with the chondrichthyes. So look, what kind of organisms are in this group? Sharks, skates, rays. These guys are kind of dorsoventrally flattened, right? And then there's also another one that's interesting that's called a ratfish. I'd have never seen a ratfish, but anyway, that is also grouped within these chondrichthyes. Notice that sturgeon are not. That's the confusing thing. They think that sturgeon are so ancient. They do have a lot of cartilage in their skeleton, but they also have some bone. And so they're actually not grouped with this particular group of organisms. So remember that we do have a shark called a whale shark. That is a whale. That is a shark, not a whale. That is a fish rather than a mammal. So let's look at some diagrams or images of these. This is my shark. This would be like a stingray. And this is what a ratfish looks like. They're also called chimeras. Okay. When we look at some of the unique characteristics of this particular group, is one of the things is that they have no swim bladder. And what this means is that they are not buoyant. So they will sink to the bottom if they are not swimming. So that is kind of a disadvantage, right? There's these really interesting images of sharks mating. The male, it's internal fertilization. The male uses a pelvic fin to insert his sperm. They start at the water, the top of the water, and then they come together, and then they fall through the water column, hit the ground, and then come apart. So it's kind of like this beautiful mating dance of sharks. So we'll talk about this swim bladder because this is super important for the evolution of bony fish, but also for the evolution of us.